Outstanding, the ultimate accolade for teachers. We challenge primary teacher Halima Hussain to go from good to outstanding. A top inspector will observe one lesson. 2 experts will fine-tune her practice and beef up her presentation. She then gets 2 weeks to take on the advice before the inspector comes back for the final verdict.
Going to outstanding? Hold on. That's actually a big thing. This is my 3rd year of actually teaching, and it seems like a very long time, but in teaching it's actually quite new, and in teaching doesn't matter how long you've been teaching, 10, 20 years, you're always learning and you've always got room for improvement.
Brampton Primary is a 3-form entry school in East London. The school rates Halima's teaching as good.
When I say freeze, you just stop there and I'll come and touch your shoulder and ask you what you're feeling.
What are you doing?
Freeze.
Can we up, miss?
To be told that I'm good, the idea of that is, wow, I'm good, I'm trying to sink that in, and then going to outstanding, hold on, that's actually a big thing. I'm actually quite critical of myself. I'm always prepared, I do background research pretty much every lesson, and my marking will always inform me as to how to continue the following lesson, which is an aspect of good teaching.
This year, Halima is teaching a Year 4 class and will focus the Good to Outstanding challenge on her science lessons.
I think my teacher is excellent because she makes the lessons fun.
I think she does her job very nicely. She's strict, she's funny, and she's kind. All 3 mixed together. I like her as a teacher.
If you can't finish a conclusion, don't worry, we're going to finish it next lesson. I'm not going to say I've got outstanding qualities as of yet, because being in teaching for 2 years, I haven't reached that goal yet, but I hope to reach an outstanding goal very soon.
It's the day of her observation.
Ooh, very anxious, and I don't know how to cope with her at the moment, so I'm trying my best to do some breathing exercises, see how that turns out.
With hundreds of inspections under her belt, School Inspector Claire Gillies leads inspection teams up and down the country. She certainly knows an outstanding lesson when she sees one.
I'm at Brampton Primary School to see Halima Hussain teaching Year 4 Science.
Halima has got a 70-minute lesson to impress our inspector.
So now we're going to do an investigation today to find out whether taller people have longer hands than shorter people. Let's look at our vocabulary for the day, and I'm going to have this up all day long for you to use. Measure.
Measure.
Victoria, do you know what measure means?
It's like when you measure your forearm.
Good. When we measure something, we use something to find out how long or how big it is. Well done. Good girl. Predict.
Predict.
What does predict mean, Danielle?
Say when we did like trying to find out which material to keep the tea hottest.
Well done. Carry on.
Guessing which one might keep it the hottest or something like that.
When I observe a lesson, I'm looking for lots of exemplary features, but very convincing high-quality learning from certainly the great majority of children in the class.
Riley thinks how tall you are does not affect the length of your hands because taller people do not have longer hands because. And the last kid, he's predicted taller people have longer hands because. Now you're going to go to your topic tables and then you've got to write one of these predictions out and you've got to finish it off.
I like it when we had to predict 3 different things and say why would you want to predict that.
Remember to keep the tape measure stretched. If you leave it loose, it still won't be a fair test and the results won't be reliable. In your science books, you write the person's name, you write their height in centimetres, rounded to the nearest centimetre, and the hand length.
When you do experiments, you find something new. You're not doing the just boring thing. You find something new, which I like. I like to discover things, and science is a subject that you can do that.
131. There we go. That's 60 centimetres.
Now we've got a few minutes to look at our results. I'm going to quickly look at someone's book instead of making it up. 16, 15, and 15. Interesting. As they get taller, do the hand lengths get taller? Do the hand lengths get shorter? Or do they stay the same? What happens? Look at your prediction. Is your prediction supported or not?
When you do science, you actually discover new things. Because if there wasn't science, you wouldn't discover new things from scientists.
Okay, let's just get a few suggestions of what you found out. Did the hands get bigger as the person got taller? Shiransi, what did your results show?
When you're shorter, your hand length is smaller, but then when you get taller, your hand length gets bigger.
Okay, so what was your prediction then?
My prediction was that the longer you are, it doesn't affect the length of your hand.
Oh, okay, interesting.
With time running out, Halima has to cut short her plenary.
Put these in your books, tidy up everything, leave everything and get your coats and line up.
So how did Halima get on?
Halima, thank you very much. It was a really enjoyable science lesson there.
Thank you.
We've got lots of support and sort of encouragement all the time, which is excellent. You made it all fun, that's the great thing, you know, it was all quite jolly. So that was lovely. And there were just little sort of small bits and pieces here and there that didn't quite come off. Would it have got us off to a speedier and more accurate start if we'd had a demonstration of measuring really well with two of them or something?
I think so, definitely.
Clearly we ran out of time. I think it would have been nice to have got to that crunchy point, you know, whereby they could sort of say, oh, they do always, or no, it's not so straightforward, because we had some lovely different predictions, didn't we?
Definitely the lesson went too quickly at the end and I didn't spend time with the plenary, so I couldn't establish what every child found out, to be honest.
It's always that interesting element with science. Why are we interested in whether our hand and our height are linked in any way? Just so that as a thought, if we did head circumference and hands, we could have been considering, it's a bit absurd this, but manufacturers making hats and gloves, and does the size increase?
Oh, right.
I think what we wanted young people to realise from as early as possible that science underpins so much of their lives that it's really vital that everyone has a good understanding of science. And I think your lesson as a whole, I would say, was a good lesson. I hope that's what you felt as well. So thank you very much. I really enjoyed the afternoon a lot.
There were little technical things which I need to improve on, like the time management. Maybe if I did less work on the carpet and more of them doing independent work, that's something that would improve my lessons and further their learning.
The inspector highlighted Halima's need to consider the context of her science lessons while keeping a watchful eye on her timings. With the first observation behind her, it's time to bring on the experts. To boost Halima's progress, help comes from voice and communications coach Ulrika Schulte-Bauklow and primary science consultant John Stringer. They start by watching Halima's lesson.
Remember to keep the tape measure stretched. If you leave it loose, it still won't be fair test and the result won't be reliable.
What did you think about her way of communicating with the children? Did you feel she'd really got them in the palm of her hand?
I think she does, but I feel she could do definitely more. I noticed in the moment where she tried to demonstrate things, it was not as clear as it could have been. So I will work mainly with her on how to make herself more expressive.
This is a very brave lesson, I think, because this is an open-ended investigation. It's courageous to let the children roll on this question and find out their own answers. In fact, she has a problem because sometimes they don't come up with what she's expecting, and she has to handle that as well. And I'll be picking up on what to do when you don't get the answers you're expecting, because that can happen to the best of us.
Halima, it's good to meet you after watching you on film as I have. When you were at the whiteboard and you were looking at the table, you suddenly realised, I think, that the figures you'd taken...
Yes.
Go on, tell us more.
I should have had some results up rather
Yes.
than getting just randomly another child's book and looking through them. And then I looked at them and I was like, okay, this is not going to work. But I had to put it up. I didn't want to go and get another book out.
This is reality. This is science.
I guess, yeah.
Science doesn't always do what you expect it to do. Some of us would use idealised data. So here are some perfect children who, just by chance, happen to have hands that get larger nicely as they grow taller. But in reality, this doesn't happen. This is an enormously helpful thing for children to learn about because it's their opportunity to discover that science isn't finite, science hasn't finished, it's always growing. We're learning something new from it. Very often the differentiation is in the degree of presentation. So, for example, you set the class going and you say to a group, you know, you carry on and I'll come across and check on you. You say to a second group, perhaps not so able, get as far as the first measurement and I'll come and check. And then with the third group, you say, don't do anything till I come and talk to you, or involve your education assistant. I feel too you could have involved her more. Now, I'm sure you prepared her and she knew what the lesson was about and she knew what your learning outcomes were planned to be. But to use her well is to involve her in the children all the time. So she might have, for example, been interpreting some of those questions that you were asking in your initial presentation to other children in the classrooms.
I didn't use her very effectively, I don't think.
Having made a table, which I was pleased to see them doing, the next step is then to be able to graph them. You could also have made some sort of a bar chart where, in fact, people looked at arm length for different children, but you could, in fact, have had perhaps their heights along here and then the number of children with different lengths of arm up that side. But it begins to get quite complicated, and a scattergram's probably better. A scattergram could have been interesting and might have shown a general trend.
Now tell me, 131.
I think it's important that the science has some purpose in real life. And I would look at two things. It may be that what you need to do is compare not height with hand size, but age with hand size. Now then you would perhaps begin to see that older people have larger hands. The other thing that you might think of to make the lesson more relevant is to look at skills. And they could be quite simple skills, like, for example, with hand size, can people with bigger hands hold more marbles?
Oh, right, yeah.
And then you could begin to say, well then, if we were making gloves for our class and our age range, just what size would we need them? And that perhaps would relate things more to real life.
Themselves.
At the end, things didn't quite go the way you wanted them to. And one of the things that makes a lesson exceptional and outstanding is to be able to accept that and to come to terms with the fact that you didn't get the result you were looking for. And remember, if you're a year 4, you want a perfect answer. You want your graph to look just right. And life isn't like that.
Yeah.
And one of the things they've got to accept is that their graph may not show exactly what they were expecting.
Ulrika works with Halima to make her gestures more expansive and improve her articulation.
And now we take our hands to do ooh-wee, ooh-wee, ooh-wee. Ooh-wee, ooh-wee, ooh-wee. Pitta, patta, pitta, patta, pitta, patta, pitta, patta, pitta, patta, pitta, patta.
Combining demonstration with clear verbal instructions can help Halima communicate more effectively with her pupils.
You add a tea bag into this mug. You place it down. Then I take the kettle.
Put the kettle on, switch it on so it boils. Once it's finished boiling, take the kettle off, pour the water into the mug, put the kettle back.
Show me how it tastes.
Comme ça.
So, just let's put things together and just try to take the principles you just learned by communicating how to make a cup of tea onto this chair.
Okay, you'd get your tape measure, so stretch it out and read out how tall it is.
Great.
How was that?
How was this?
A lot easier demonstrating and talking rather than just talking at the children, expecting them to go ahead and do it.
You also highlighted with your articulation the words which you felt were crucial, like bottom
Yes.
and 0, etc. Got the idea?
I actually treated you like a child there. Demonstrations are very important, and she's taught me that. Using my body helps myself and the children, so that was a bigger shock to me, thinking, oh, gestures, is it such a big deal? But yes, actually it is a big deal for the children and for myself.
Back at school, Halima and Deputy Head Elizabeth Bradshaw reflect on last week's observation.
Put these in your books, tidy up everything, leave everything and get your coats and line up.
In an ideal world, everyone would fit in a perfect plenary.
It was rushed and I should have actually thought, okay, we're not going to go to our tables and we're not going to look at our results, we're just going to look at them together on the carpet.
Maybe if you just kept their results as they recorded them and then rank the whole class on the interactive whiteboard as an activity that you do all together. Yeah.
So, with Halima's final observation just weeks away, it's back to the classroom to put all that advice into action and raise her game.
So your learning intention is to classify and describe the differences between solids and liquids. I do believe I did articulate my words and I used gestures. I used as much gestures as I could in that lesson. So you're going to get each object, you're working as a whole table on your topic table, okay? Topic tables. One of the things that I should have done more was getting the children to go back and forth from table, doing an activity, coming back again. And in this science lesson, I got them to actually go quite quickly to do some classification, then come back and then go back. So throughout the lesson, we were doing quite a few movements rather than sitting there the whole time. Try and describe how it looks. It moves. Good boy. So put that in the right place, Daniel, and then next person does the next one.
Okay, can you find the marbles for me?
I've used my EAL coordinator quite effectively by getting her to interact with the children throughout the lesson, not just during the main activity, but also on the carpet. Yes, miss?
But we talked about what happens when you move the cup. What happens to the team when we move the cup? And what did we talk about?
Polar seems to want to say something there.
It's team move.
Say that again?
It moves.
It moves,
Yeah,
exactly.
it moves.
Liquids, always, when you put it in a container, the surface levels off. Can you see that it's straight, it levels? I did use a lot of the ideas about my body and moving around. I used actual things to show the children what I was talking about. When I was talking about liquid, I would actually bring the liquid out and pour it to show them what I'm talking about. Okay, we're going to have to stop and get ready for playtime. Can you get me a bell? Today in science we will be measuring the volume and make careful observations of lots of different types of liquids. Whoever measures things at home or in class? Anyone? Hands up? I always do. So this skill you're going to be learning today in science is very important at home, at school, in all different places. I took a lot of John's advice on in this lesson, relating things to real life and explaining things clearly. Now, why do you think your measurements are completely different?
The jugs are different sizes and you measure it.
It's not a case of the jugs are necessarily different sizes. We know they're different sizes, but the jugs were produced inaccurately. One of the biggest part of what John taught me was if results don't go according to plan, that's fine. Tell the children that and explain why. The people who made these jugs didn't make them as accurately as they could have. That's why that table's results were very, very different. Okay? I definitely think I'm making progress from my very first observation. I can see it quite clearly. Before it was sort of I'd have to consciously think I've got to do this in the lesson, and because I'm using it all the time, it's quite natural now.
With Judgment Day looming, Halima gets some last-minute advice from John Stringer.
Linking it to real life, I used it as I've asked a child to get me X, Y, Z solids, and the child had put them all into one container, whereas I wanted them into separate containers. Is that a reasonable link to real life?
I think there's some gardening and building opportunities here as well, because there's builders need to work with different sizes of gravel and stones and so on. The one I always use, of course, is the great mistake where things have got mixed accidentally and I want to separate them again.
Excellent. Thanks a lot, John.
Let us know how you get on.
I will do.
Okay.
Bye-bye.
Bye-bye.
Bye. I'm actually worried about whether I'd get to outstanding. I know it might not necessarily happen because it's a lot to do in such a short time. So I'm aware of the fact that I won't necessarily get to that stage. It might happen in a year or two, but just the idea of not getting there after all this hard work is actually quite upsetting.
The day of Halima's final observation has arrived.
I'm kind of a bit excited about doing it. So right now, the nerves haven't kicked in. 3.
Claire Gillies is back, and it's crunch time.
The last time I observed her, her teaching was definitely good, so I'm really interested to see what strategies she's taken on board to make her teaching even better.
Okay, today in science, you'll be choosing appropriate apparatus for separating a mixture of solids. Let's look at our vocabulary. Solid.
Solid.
We've looked at lots of solids. Stevie, can you name me one solid?
A rock.
Fantastic. Larger.
Larger.
Everyone do something larger. Very good. Smaller.
Smaller.
Show me smaller than large. Good. Apparatus.
Apparatus.
We're going to use apparatus to separate the mixtures. What does that mean? Polar.
It's something that we're going to use.
Fantastic. Something we're going to use. A type of tool, okay? Some jobs require you to separate different solids that are mixed together. If you're a gardeners sometimes have to separate the stones from their soils, or builders have to separate things. So let's see if you can use that skill and then use it at home when you need to.
The way Mrs. Sin explained the learning intention was very good. I understand what to do, and if you ask me a question based on that topic, I will know it.
Here's a bowl full of a mixture of solids, and you're going to first plan of which solid you're going to take out first. And I want you to write that down in your books.
So first of all, we need to take out the coins and paper clips so that they're separate.
Then we do the big particles, okay?
If you put all of that in there, all the
Look, what do we want to come out? The sand. Will the sand go through the sieve?
We worked as a whole table while the others were working in threes, and we had 2 bowls, but we worked as a whole table to communicate with each other.
Now, who would like to do the separation of the marbles? Let's see if Iqbal can do it effectively. Could you possibly use 2 spoons to help you out? Go on then, Shannon. Good teamwork, this group. All right.
We should have done the sand last.
Okay, think about what you've just said, because we're going to talk about that.
It was interesting because I never knew that you could actually use like a spoon to separate 2 different solids.
Now I'm going to ask you to share if you were able to separate all the solids from the mixture. Naeem.
First we done the sand and the rice.
With your one, what went wrong though?
We should have done the sand last of all.
They decided to do the sand, removing the sand from the rest of the materials first. Now when you do that, and you've got coins and you've got cubes, what happens to the sand?
It goes into the magnetic stuff and
into the cubes? They went inside the cubes, so you didn't actually remove all the sand, did you? Miss McDougall.
Danielle, what did we do first in our group?
Oh, okay. Did it work?
Danielle?
Yeah, it just kept on shaking the sieve.
Ah, putting the whole contents into the sieve straight away would have been a lot easier, and it would have worked just as effectively by the looks of it. Thank you for letting me know. Excellent.
With all that expert advice and weeks of practice behind her, will Halima have made the grade from good to outstanding?
Halima, thank you very much. I really enjoyed seeing all that incredible thinking going on in that science lesson. You could really feel their brains were buzzing. We had some really good fun, and they worked very hard, and I hope you felt pleased with what they'd achieved in the time. It was a very stimulating lesson all round, and it's some of the things behind that really contribute to that. And the sort of key ones I jotted down, I thought was the very careful planning, particularly of the groups. That it wasn't just, this is the absolute top ability group, this is the absolute weaker group at all, because you had some positioned in a way that they would bring on some of those who weren't quite so strong at writing or whatever. Your opening was warm and welcoming, and you did, I wrote down, use some very nice sort of hand gestures for sort of large and small and all those. It was just wonderful to see some of the unusual thoughts emerging. I mean, I know we both enjoyed that table, didn't we? The one in the corner.
They didn't think, oh, we could just put it all into the sieve. I don't know why it didn't connect with them. Maybe they thought they had to use an implement to transfer it, possibly.
And it's, in a way, you could argue it's healthy for them to sort of go off at tangents and sort of have some strange ideas. That whole sort of lovely human touch at the end when you say, well, I've learnt something there, when they,
I did actually.
when they were confronting you with a different way of doing something.
I was glad they pointed that out. My additional adult thought, oh, the children are not mentioning it, so she'll mention it.
I was going to say another strength was what she did with her group. You know, she really did keep them focused, moving on. She was certainly helping, wasn't she,
She's very good with
to
the
keep
children.
the lesson going on fast. I think if we look at it as a whole, I think we really can see that although I'm sure there's one or two little things you'd say, oh, I wish that had happened or whatever, that it was an outstanding lesson overall because they really learnt hard, they really worked hard, and you were guiding them, and I was very happy to watch it, so thank you again.
Thanks a lot. I didn't realise how much it would mean to me, but I feel like now I can do so much more than I could do before. My lessons are going to be really good from now on because I know I can do it. I can't wait to my next science lesson. So happy.